Hey, Inorganic Chemistry, we're back, and we are going to move on to experiment 5, which is the epoxide opening reaction. You can see it right there. So basically, we made this styrene oxide a couple of experiments ago with the manganese complex, or at least we tried to. We definitely made some, but the yield wasn't great, as you all know. So we fortunately have a bottle of styrene oxide right there, and we're going to use that and open it up with methanol. And so methanol will be the nucleophile that comes in and opens the epoxide, and we're going to evaluate your 3 different catalysts to do that. So here on the table, I've got your 3 different catalysts, 3 different reaction vessels set up, a control. I'm just going to set up one since I'm doing all this myself, and there's no need for 3 identical ones. And pretty much got everything I need. So the first thing I'm going to do is go ahead and weigh out the catalyst and what's called lutetium paratoluene sulfonate, and lutetium is basically a pyridine derivative, and you all know that paratoluene sulfonic acid is just sort of an organic acid that is used for acid catalysis of reactions, and so all that this is sort of a convenient material with a slightly different pKa that, so basically the pyridine has deprotonated the paratoluene sulfonic acid, and so that's this compound. We call it LPTS. There's actually a description of the synthesis of that here in the manual. That's really for a TA to do, but we actually did this in mass before, so we should have plenty of it. We only need 13 milligrams. It's really just an acid catalyzed reaction. So yeah, I'm pretty much all set up, so I'm gonna go ahead and get started. Okay, so now we've got catalyst and LPTS and all of these vials, except of course for the control, which just has LPTS in it, so no catalyst. So again, the control should be everything except for what you're evaluating. In this case, that is the catalyst. So everything will be identical except for the presence of that cobalt catalyst. So next, if you read the procedure, you'll see that we're supposed to add a mixture of methanol, styrene oxide, and acetonitrile to the cobalt complex and LPTS in an ice bath. So the first thing I'm going to do, or the next thing I'm going to do anyway, is mix the styrene oxide, the methanol, and the acetonitrile into each of these 4 vials. I'll make 4 identical vials, and then I will just cool down the round bottoms in ice baths, which we've got right there, and then we will cap them, let them run for a week. So that's the plan. Okay, so now I have actually modified the procedure slightly. So here is just one of the stations with the saline away round bottom. And as you can see, I've submersed the vial that has our methanol, acetonitrile, and styrene oxide in it. So that way that's gonna be nice and cool. Then I'll switch them, put the round bottom in there, and then dump the vial in and let the reaction start. So you can see I've got that one there, there, and there. They're all blinking because their heat is not on, but it's just detecting the cold temperature of the ice bath, and for some reason that's making it blink. But all right, anyway, I'm gonna get the just the video showing me adding these, and then that'll be it for a little while. All right, so here we have our reactions going. I'm going to just let them sit on ice and react. There's our control. And I'll get them a little bit later, either this week or maybe next week. We'll kind of see how things go. The next step here, just looking at our procedure, is to dilute with diethyl ether, filter through a plug of silica gel, and that's pretty much to remove the cobalt catalyst. All the ether should precipitate the catalyst, then the silica gel should remove it. It's not really for any other separation than that. And then you just rotovap that down and get an NMR, and we'll see what we get. So again, styrene oxide should be has a high enough boiling point that we shouldn't lose that. So if there's any unreacted styrene oxide, we should see it, and our product we should see as well. Although if you notice, and this is something I want you to look out for, in the manual here, you could get two different products, right? If you think about it, methanol as a nucleophile can attack in two different positions and form two different products. So you could get one or the other or both, and it may be different from one catalyst to another. So I've included both of the NMRs of the possible products. So that's just something to look out for. So I'll upload those NMRs either later this week or next week. We'll just kind of see how things go. You know, life's kind of crazy at home, balancing the kids, so I don't really know exactly when I'm getting in, but sometime within the next week I'll get in, run the NMRs, and get that done. Anyway, I'll see you guys later. Hope you are all well. Talk to you soon.